All right. Hello, and welcome to the first of your geometry lessons with me, Mr. Kriskowski. As you can see, we're going to go ahead and jump in. We are in Unit 1, which makes sense since it's like the first day of school or one of the first few days of school. We're going to be working in Chapter 1 of your geometry book. If you're watching this after you have your laptop, you'll be able to download that, and there'll be a link on Google Classroom, and I'll have everything you need to know about Google Classroom and all that already communicated to you. If you're watching this on the first day of school, you can't really do that yet, but I'm going to leave it on there because that's where we're headed in the next couple of days. But man, I'm fired up to watch this video with you and listen to my fantastically lovely voice and show you some math. So here we go. The title of this lesson, Points, Lines, and Planes. You're going to identify and model points, lines, and planes, intersecting lines and planes, and if you're like, I have a pretty good idea what those words mean, then you're in luck. You're in good shape. If you're like, man, I'm not sure what those words mean, you are also in luck because I'm going to teach you. This is going to be beautiful. So here we go. Buckle up. This is a definition, explanation, and it's kind of small, but I'll hit those highlighted points. It says a point is a location. No size, no shape. It's just a location, and we label it with a letter. Okay, and you can see the example here, point A, right? You put the letter next to the point. That tells you that thing is called point A. Now, next, we have a line. It's made up of points. No thickness, no width. Any 2 points will form a line. Now, I want you to pay particular attention to how we name lines, okay? And you can see in this picture, we got 2 points on that line, P and point Q. We can call this line PQ. We could call it line QP. And if you look closely, you can even see the symbol for that, right? It's a P and a Q or a Q and a P with a little line doodad above it, right? That's how we label this line. Again, PQ or QP, that's the name of the line. Another way to name lines, however, is sometimes they'll do this thing where there's like a little lowercase letter right next to the line. And so in this one, they've labeled it line M. So there's a third name for that. You could call it line PQ, you could call it line QP, or you could simply call it line M. All right? Next, we go to a plane. A plane, not like an airplane, a plane. A geometric plane, a flat surface made up of points that extends in all directions. If you look up at the ceiling, look down at the floor, look at one of the walls, and imagine that extended forever in all directions, that flat surface going forever in all directions, that would give you some idea of what we're talking about when we say a plane. All right? Now, when we name planes, a couple of things you need to know, right? You can name planes by naming 3 points that are in that plane as long as the points are not all on the same line. And we'll talk about that a little bit more here on the next slide. But we want to have 3 points that are not on the same line, and we'll name the plane with those 3 points. And so you can see all the different examples. You can see point D, point B, and point C are all in I got that little notification there. One of my friends has a birthday today, so there you have it. But we could call it plane DBC, plane DCB, plane BCD, plane BDC, plane CBD, or plane CDB. I think I said them all correctly. I didn't read them in the order they're on there. But then there's one more way to name a plane. If there's a capital letter, right, like a capital, it says a capital script letter. That's like cursive. It's hard to make one single letter in cursive sometimes because that K kind of just looks like a regular K. But that would be another name for that plane, plane K. Okay, so we could name it with 3 points. 3 points names a plane as long as the points are not on the same line. Or you can name it with just the one letter that labels that plane, plane K. All right, let's talk about collinear and coplanar. This is good stuff. Collinear. And if you're like, man, I don't know that. I've been doing this for a long time, and sometimes I hear the word collinear, and I want to say, well, it's just what it sounds like, right? Co meaning with or together, and then linear meaning having to do with lines. So when we talk about collinear points, we're talking about points that are all on the same line. Now, any 2 points will always be collinear because any 2 points will always form a line. But what if we have 3 points? 3 points could be collinear, or they might not be. Depends. Are they all on the same line or not? Okay? Coplanar points that lie on the same plane. So we talk about collinear or its opposite non-collinear, coplanar or its opposite non-coplanar. And those are words that we need to get used to. Okay? There's going to be a lot of vocab. Gosh, So much of geometry is simply vocab. Vocab, vocab, vocab. And so, some key vocab today: point, line, and plane, collinear, and coplanar. All right, and you'll get a closer look at this in a little while. Look at this. They want us to, in this practice question, they want us to name a plane that contains points T and Z. Now, you'll notice something about point T. Point T is not in that blue plane P. It's not. So if we want to name a plane that contains T and Z, you can choose point T, point Z, and then any other point, right? Any other point in that picture, and that would be the name of a plane. I gave you one example. TZX would define a plane. So you could name a plane TZX. You could also go with TZY or TZW or TZV. Could you go with TZN? No, because N's not a point. N is a line. Could you go TZP? Nope. P's not a point. In this picture, P is the name of that plane. All right? Okay. All right. I'm going to keep moving. But when you get to do these on your own, you can pause, you can rewind, you can do all kinds of stuff. All right? There we go. I like to say, all right. Sorry, it's a bad habit. I'm working on it. I'm going to try not to do that as often as I used to. Anyway, it's a little distracting. Sometimes we have these speech habits that are distracting. You ever know somebody that says or like a lot? What's the deal with saying like? I was like, yeah. So mine is, I say, all right, at the end of, after I explain something. So I'm working on it. But anyhow, TZX. What about a line containing point T? Well, you could say line TZ, line TY, line TX. You could also say line R. Because if you look at the picture, line R contains point T. Point T is on that line. You could also say TW, you could say TV. And right now you're thinking, well, yeah, but they didn't draw a line from T to V. Well, yeah, but it's not too hard to imagine. Shoot. I'll move this up. I can do this. There is line TV. Here is line TX. So kind of see how that works, kind of get the idea. All right, cool. We'll move that up. Now, intersections. Intersection is where two things come together. You know the word intersection, right? The intersection of 135th Street and K7. Right? What's at that intersection? Oh my goodness, what isn't? Walmart, the Walmart gas station. Let's see, what else? You got Great Clips on the other side, Papa Murphy's. You got Room Music over there. And one of the other corners, we've got like Price Chopper and now Chipotle. Starbucks coming in. Is that Starbucks open yet? I don't know. I'm not really a Starbucks guy. I'm not anti-Starbucks. I'm just not a big coffee guy. I'll do coffee occasionally, but I'm not like, I have to have coffee. If I don't have my coffee, I can't even think. I'm not that guy. And maybe you know people like that. Maybe you're like that, and that's okay. My wife's got to have coffee in the morning. I think it's more of a habit than anything, but whatever. Intersection. Excuse me. Set of points that they have in common. The intersection of two or more geometric figures is the set of points they have in common. Two lines always intersect in a point. You're going to need to know that. Okay? Lines can also intersect planes, and planes can intersect each other. Now, if two planes intersect, what does it make? This is a great question. If two planes intersect, like plane A and plane B here, it makes a line. In this case, they labeled it line R. But if two planes intersect, it makes a line. Now, if you don't believe me, look up at the ceiling, okay, and look at one of the walls. Look where the wall meets the ceiling. What does that make, man? It makes a line. It's pretty cool. You can actually see that happening in real life right here in front of your face. Wow, good for you. That's cool, man. So here's what they wanted us to do, and I'm just going to kind of walk you through this. It says, draw and label a figure for each relationship. Okay. Now they got a coordinate plane there. I hope that doesn't scare you. All right. But they walk you through this boring story. Lines A and B intersect at E, and then they give you the coordinates of point A and point B. Line AB and line CD intersect at point E, I should say. And they give you those coordinates. Point F is coplanar with these points, but not collinear. Right? And then they drew point F down here. There's F. They could have drawn F over here, or here, or here, or here. Okay. Anyway, that's kind of fun. Part B, QR, line QR intersects plane T at point S. And there they drew that, right? Cool. You can see how line QR intersects plane T at point S. When a line intersects a plane, right, it kind of goes through it like an arrow, going right through that thing at a point, and that point is called S. And they walk you through those steps. Draw the surface to represent plane T and label it. Okay, cool. Draw a dot for point S, and then draw points Q and point R, one above, one below. Bam, there you go. All right, cool. Let's move on. Definitions. Definitions. Now, something I got to show you, I got to go back a little bit. We got to go back to point, line, and plane. I skipped over this at the beginning. Point, line, and plane are undefined terms. We don't have definitions for points, lines, and planes. Now, they explain what they are. So I don't literally mean that you can't look them up in the dictionary, but for the purposes of geometry, we say that point, line, and plane are undefined because those are the terms that we will use to build upon. We get all of our definitions, right, from previously defined terms, and it says that here. All right, definitions are explained using undefined terms and other defined terms. So we get definitions from terms that we've previously either defined or at least talked about. Okay? So if I asked you, what are the 3 undefined terms in geometry? You should know that. That question's on the board, by the way. What are the 3 undefined terms? Anyhow. And then we get to this dude. Space is defined as a boundless 3-dimensional set of all points. Space can contain lines and planes. Space contains everything that exists. Wow. That's pretty beast, man. Anyhow. So you can see those questions at the bottom looking at that picture. Are points E, D, F, and G coplanar? E, D, F, and G. Are those coplanar? Are they all in the same flat surface? E, D, F, and G. Well, E, F, and G are all in the same flat surface. I don't know about point D. Point D is like at the top of that pyramid there, that pentagonal pyramid. All right, cool. At what point or in what line do planes JDH, JDE, and EDF intersect? At what point do all 3 of those planes intersect? JDH, JDE, and EDF. JDH, that's like that. I mean, it's a plane, but it's represented in that thing by the triangle. JDE is a different triangle. And then EDF is a third triangle. And what we're going to find is that those 3 planes intersect at point D. It's weird to think about planes intersecting, 3 planes intersecting at a point, but it's actually not that hard. If you look at like where the ceiling and 2 walls meet, they meet in a single point. Okay, the ceiling meets one wall at a line, the ceiling meets the other wall at a line, but where do those 3 planes meet? At a point. And it's funny because as I'm making this video, I'm actually, even though you can't see me, I'm turning and pointing to where that's happening here in the room, which is useless because you can't even see me, but it helps me think about what we're doing. So anyhow, I hope you enjoyed the video. We're going to have a little assignment to work through. But yeah, this is great. Good stuff. Thanks, everybody.